Hello everyone, my name is Mikhailo Bagmut. I present an article, a method for performing the operation of adding two residues by Modulus by Viktor Krasnobaev, Alexander Kuznetsov, Mikhailo Bagmut and Tatiana Kuznetsova. Talk about relevance. One of the components of a computer system is the positional binary number system is an adder of two numbers. In particular, the components of the CS are also adders modulo m of the two numbers. This type of modulo adders is widely used both in the PNS and in the non-positional number system in the residual classes. So the adder of numbers in the RNS will consist of a set of k adders modulo m. In this aspect, an urgent scientific and technical problem is the problem of constructing adders operating according to an arbitrary modulus ME of the RNS. If the residues A and B of numbers in the RNS are represented in a binary PNS, then the adder of two residues A and B modulo M is sequential collection of n binary 1-bit adders. The purpose of the article is to develop a method for performing the operation of modular addition of two residues of numbers modulo M arbitrary based on the use of a binary adder modulo M. The article provides examples of concrete execution of the method for performing the modular addition operation for various values of the residues A and B. The analysis of the considered example showed the practical applicability of the method proposed in the article for performing the operation of modular addition of two residues of numbers A and B modulo M. The method proposed in the article for performing the operation of modular addition of two residues can be used both in the PNS and the residues of A and B numbers modulo M based on the use of binary adders consist of a combination of the following actions. First action, the structure of adder modulo M is determined. Second, the operation of bitwise addition modulo two adders A and B is performed. Third, the result of the operation of bitwise addition modulo two residues A and B is placed in the corresponding binary 1-bit adders of the adder structure modulo M RNS. Fourth, based on the modular addition scheme, an algorithm for adding two residues A and B of numbers modulo M RNS is implemented. The presented method has limited application, so in the case of equality of two residues A and B, the result of modular addition will not always be accurate. This is due to the fact that the result does not always take into account the relationship between the values of the modulus M and the value of the sum A plus B of positional addition. When developing a new method for adding the residues A and B, it is necessary to take into account the options for the relationship between the values of the modulus M and the value A plus B of the result of positional addition of the residues of numbers. Consider a new method for adding the residues of A and B numbers modulo M, a new method for implementing the addition operation from a combination of the following actions. First action, for the value of the modulus M, the synthesis of the adder modulo M is performed. Second, the result of summation A plus B is determined. Third, the result of the positional compression of the result A plus B of addition and the value of the modulus of the adder M is determined. Fourth, if the addition A plus B smaller than M is fulfilled, the result of the operation is the value of the sum A plus B. When the condition A plus B greater than M is satisfied, the result A plus B of positional adding is bitwise entered into the corresponding bits of the OBA. 6. In accordance with the algorithm for adding two residues A and B of numbers modulo, the operation of adding two residues A and B of numbers modulo is implemented. Experiments and results. You can see the example of the adding residues A equal 5 and B equal 4. The adder implements the operation of positional of these residues in the form A plus B. The value of the sum will be 1001, determines the result of the operation. Table 1 shows, figure 1 shows a scheme of the addition of residues A and B modulo M equal 11. Figure 2 shows adding of the residues A equal 5 and B equal 7. The adder implements the operation of positional addition of the residues A and B in form A plus B. The value of the positional sum will be A plus B equal 1100. Is bitwise fed to the corresponding input of the OBA from 5.4 till 5.1. Thus OBA of the adder contain respectively the values 1100. The modular addition operation is implemented according to the modular addition scheme modulo M equal 11. The algorithm for the implementing a modular operation is presented in figure 2. The unit of the binary digit is supplied to the input OBA 5.3 and 5.1. The number system in the residual classes is a promising direction for the qualitative improvement of modern computer systems. In particular, the execution of integer computational operations can be significantly accelerated by reducing the bit depth of the computations. Performing operations on a large modulus can be replaced by several operations on small modules, and this is at the heart of the computational operation in RNS. We have considered the simplest operation of addition of the residues modulo and arbitrary. These calculations are used both in the traditional positional number system and in the number system in residual classes. The article describes a new method for performing the addition operation A plus B modulo M of two residues. The addition operation is implemented based on the use of the structure of a binary adder modulo M of RNS, and also taking into account the scheme for adding two residues A and B of numbers. The method for constructing binary adders modulo M is based on the structure of an adder modulo, which consists of a set of sequential binary 1-bit adders. Examples of executing the method of performing the addition operation for various values of the residues A and B are given. The analysis of the considered example showed the practical applicability of the method proposed in the article for performing the modular addition operation. The proposed method can be used in various computer applications, including for improving computing performance, providing fault tolerance, etc.